out why these teams ended up this way, as well as all the other teams. And we found that 4 basic variables were the most important factors: offensive and defensive passing ability, and offensive and defensive rushing ability. And we based these on yards per attempt instead of total yards. We also tried to use entity-fixed and time-fixed effects, but we found that these did not improve the explanatory power of our model, so we discarded them and just went with these 4 basic models, or 4 basic variables. This models passing yards per attempt on offense to wins, and as you can see, it's a pretty positive correlation. The adjusted R squared, which is a measure of explanatory power, for just this variable is 0.38, which was the highest of all our 4 variables, but very high considering it's only 1 variable. This is the opposite. This is passing yards per attempt on defense. Again, it's a very strong correlation, this time negatively. The next 2 graphs model rushing yards, and as you can see, the correlation is not as strong. Rushing yards per attempt on offense and defense had an adjusted R squared of 0.03 approximately. And here are some descriptive statistics of our dependent variable and the 4 independent variables. As you can see, an average team would win about 8 games out of 16, with rushing offense and defense at about 4 yards per attempt and passing offense and defense at about 5.9 yards per attempt. So after running a linear regression with our 4 independent variables, these are our results. All variables were statistically significant to a very high level. Our F value was 287.97 and our adjusted R squared is 0.6659, which both commend our model as being pretty accurate. Our root mean squared error for predicting wins was only 1.75, and there was no variance inflation caused by multicollinearity. To summarize, passing offense and defense are by far the most important statistics that we've found. Rushing offense and defense is also statistically significant.